Hi everyone! Okay, so in this video I'll be talking about the Fourier transform. So let's start off with the definition of the Fourier transform. Okay, Fourier transform. If I apply the Fourier transform to a function f of t, it will equal the function in the frequency domain. And you can find that by doing the integral from negative infinity to infinity of f of t to e to the minus jwt dt. And the inverse of that, oh yeah, that's how you spell inverse. Inverse Fourier transform. Transform is written as fancy f inverse of the function. No. Since it's the inverse, you're applying it to the function in the frequency domain. Yes. So it's f w, not f of t, which equals 1 over 2 pi of the integral from negative infinity to infinity of f of w e to the j omega t dw. There's a t? Oh, there's a t. Okay. So let me draw this out. So you have a function f of t. This is in the time domain. That's why there's a t. And it's the same function in the frequency domain as f of w, where w is angular frequency. So you want to convert between those two, then you use the Fourier transform. So in order to go from the time domain to the frequency domain, you use the Fourier transform. And it goes to here. And if you have the frequency domain, you want to go to the time domain, you use the inverse Fourier. And it's like a little cycle. It's like the circle of life before signals. And so, oh God, I'm not gonna be able to fit it. Okay, let me scroll up. Let's do an example. I have f of t equals 1 minus e to the negative bt times u of t. Let's find the Fourier transform of this. So this will be fw would be 0 to infinity of 1 minus e to the negative bt of e to the minus jwt dt. And so when I first wrote it, the bounds of the integral was from negative infinity to infinity. But because it's being multiplied by the step function, everything before 0 is being multiplied by 0. And so that cancels out. So then your bounds end up being 0 to infinity. Because, again, this is the unit step function. And so everything on this side is being multiplied by 0. And it just ends up being 0. So you just do your integral from 0 to infinity, which is that direction. 0 to infinity. Okay. So let's take the integral of this. It's gonna fit. Oh God, I need to write smaller. Okay, so I'm gonna distribute this part. So then it'll be 0 to infinity of e to the minus jwt, and I'm gonna break this integral up to. I'm gonna break this integral up into two parts, so it'll be easier. And this is 0 to infinity of e to the minus b plus jw t dt. And then from there, take the integral of each one. Is it going to fit the screen? Yeah, I think I'll make it. Minus e to the minus jwt all over jw from 0 to infinity plus 1 over b plus jw e to the minus jw of 0 to infinity. Oh, there's a t. Okay. So you just simplify it, and I'm not going to do that because I'm lazy, so I'm going to just give you the final answer. Fw equals minus bw squared minus jwb squared all over omega 4 plus omega squared plus b squared. Okay, so as you can see, doing this integral converted this function that was in terms of t to now the angular frequency omega or w. I just call it both sometimes. But yeah, that's the Fourier transform. Yeah, that's it for this video. Thank you for watching. See y'all next time.